In this lecture, we will continue our discussion about single phase voltage source inverter. Single phase voltage source inverters are classified into two types: single phase half bridge inverter and single phase full bridge inverter. The previous lecture we already discussed about the working of single phase half bridge inverter with a resistive load and with a resistive inductive load. In this lecture we will discuss about the working of single phase full bridge inverter with the resistive load and resistive inductive load. Okay, a single phase half bridge inverter consists of, what are the components in a single phase half bridge inverter? A single phase half bridge inverter consists of two thyristors, two diodes, and a 3-wire DC input supply. The main drawback of the single phase half bridge inverter is the presence of this 3-wire DC input supply. By using a single phase full bridge inverter, we can eliminate this 3-wire DC supply. Okay. Now let us see the circuit diagram of a single phase full bridge inverter. A single phase full bridge inverter consists of a DC supply Vs and 4 thyristor T1, T2, T3, T4 and 4 diodes D1, D2, D3 and D4. The diode D1 is connected anti-parallel with the thyristor T1. Diode D2 is connected anti-parallel with the thyristor T2. The diode D3 is connected anti-parallel with the thyristor T3. And D4 is connected anti-parallel with the thyristor T4. Okay. Thyristor T1, T2 and diode D1, D2 forms a first leg of the inverter. This is known as the first leg of our inverter. Then the thyristor T3, T2 and diode D3, D2 form second leg of our inverter. This is the second leg of our inverter. The load is connected in between the first leg and the second leg. Okay. Load is connected in between the first leg and second leg. The conventional direction of current flow and the polarity of output voltage is as shown in figure. That is, A terminal positive and B terminal negative voltage is taken as positive voltage, and the direction, this direction of, that is, the current flows from A to B is taken as the positive value of the output current. Okay. We can represent the same circuit diagram with the help of switches. Here we are representing the switches with the symbol of thyristor, but we can represent the same circuit with the help of symbol of symbol of switches. Okay, this is the circuit diagram. This is the circuit diagram of a single phase full bridge inverter. We are representing our thyristor with the switches S1, S2, S3, S4. We can represent this circuit like this. Okay. Now let us discuss about the operation of a single phase full bridge inverter with a resistive load. For obtaining positive voltage, we are operating the switches T1 and T2, or we will turn on the switches T1 and T2. If the switch T1 and T2 in on condition, the positive terminal of the battery is connected to A terminal of the load and the negative terminal of the battery is connected to B terminal of the load. This is the B terminal of the load. Therefore, the load voltage become, or output voltage will become plus Vs. Output voltage will become plus Vs if we turn on the switches T1 and T2. Okay. If we turn on the switches T3 and T4, then if we are turn on the switches T3 and T4, then positive terminal of the battery is connected to B terminal of the load and negative terminal of the battery is connected to A terminal of the load. That is, the polarity reverses. That means our output voltage will become minus Vs. Okay, that is By switching T1, T2 and T3, T4, we can obtain an alternating voltage, alternating output voltage. Okay. Okay. Now let us see the operation. At t equal to 0 instant, at t equal to small t equal to 0 instant, we are giving fire impulse to thyristor T1 and T2. Our load is a resistive load. Therefore, the current flows through T1, A terminal of the load, through the load, B terminal of the load, T2 and back to source. Therefore, the current is positive as well as voltage is also positive. Then at the instant t by 2, at the instant small t equal to capital T by 2, we have forcefully commutate the thyristor T1 and T2 and we will turn on the thyristor T3 and T4. T3 and T4. We will give fire impulse to thyristor T3 and T4. Then what happens? The positive terminal of the battery is connected to B terminal of the load and through the switch T3, and negative terminal of the battery is connected to A terminal of the load through T4. That means our output voltage reverses. That is, output voltage is equal to minus Vs, and also the direction of current also reverses. Direction of current when T3 T4 conduct is from B to A. That means current direction also reverses. So we get a alternating output voltage. Here we are using a resistive load. So current is in phase with the output voltage. Our output current is in phase with the output voltage since we are using a resistive load. Now let us examine the working of a single phase full bridge inverter with a resistive inductive load. Resistive inductive load. If our load is a resistive load, there is no significance for the diodes D1, D2, D3 and D4. If our load is a resistive inductive load, then only the diode D1, D2, D3, D4 come into action. Okay. Due to the inductive load, the inductor cannot allow sudden change in current. That is, the output current lags behind the output voltage. Okay. During that time, the diode D1, D2, D3, D4 will conduct and some power is fed back to the source. If our load is a resistive inductive type load, current I0, output current I0 will not be in phase with the output voltage V0, and diodes connected in anti-parallel with the thyristor will allow the current to flow when the main thyristors are in off position. Then the energy is fed back to the DC source when these diodes conduct. So these diodes are known as feedback diodes. The diodes D1, D2, D3 and D4 are known as feedback diode. Okay. Now consider the instant before small t equal to 0. At t equal to 0, we are giving fire impulse to thyristor T1 and T2. Before t equal, we are assuming continuous conduction. We are assuming here continuous conduction. So before t equal to 0, our thyristor T3, T4 will be in the conduction. T3, T4 will be in the conduction state as we are assuming continuous conduction before t equal to small t equal to 0 instant. Okay, before t equal to 0 instant, the thyristor T3 and T4 are in conduction state. That is, positive terminal of the battery is connected to B and negative terminal of the battery is connected to A terminal. Connected to A terminal. That is, the voltage, output voltage is negative. B is positive when T3 and T4 conducts. B is positive and A is negative, that is output voltage is negative minus Vs. At that time the current also flows from the terminal B to A. Therefore the current is also negative before small t equal to 0 instant. Okay. The current is also negative. At t equal to 0 instant, we are giving firing pulse to thyristor T1 and T2. So there is a sudden change in switching. We are forcefully commuted thyristor T3 and T4 and we will turn on, give firing pulse to thyristor T1 and T2. Therefore, there is a sudden change in circuit happens. Therefore, there is a change in output voltage polarity. That means here A terminal will become positive and B terminal will become negative. Okay, but due to the nature of the load, current I0 cannot change its direction immediately because of the nature of load. That means current I0 will continues to flow from the terminal B to A even after the turn off of T3 and T4. Therefore, the diode D2 and D1 will conduct and the energy stored in the inductor fed back to the source. Okay. During that time the output voltage polarity is positive. Output voltage polarity at t equal to 0 instant, output voltage is positive, but current is fed back to the source. This current is fed back to the source through the diode D1 and D2. D1 and D2. At a particular point 1, say this particular point 1, the diode current will become equal to 0. Diode current will become equal to 0. At that time, the conduction transfers from D2 to T2 and D1 to T1, and the current direction also reverses. The current direction will become A terminal to B terminal. Therefore, the current will become positive. Voltage is positive and current is also positive after t equal to 1. After t equal to 1 instant. Okay, before t equal to 1 instant, the thyristor T1 and T2 cannot conduct because due to the voltage drop across the diodes D1 and D2. Okay, there is a reverse voltage coming across the thyristor T1 and T2 due to the conduction of diode D1 and D2. So T1 and T2 will continue in its off state till small t equal to 1. Till small t equal to 1 position. After small t equal to 1 position, the thyristor T1 and T2 will become in its forward conduction mode and it will start conduction and current starts to flow from A to B. Okay, then now consider the instant small t equal to capital T by 2. At small t equal to capital T by 2 instant, we are giving firing pulse to thyristor T3 and T4. But due to the inductive nature of the load, the thyristor T1, T3 and T4 will not start conduction immediately due to the presence of the inductor. Therefore, the diode D3 and D4 conduct. Diode D3 and D4 conduct and the voltage will become negative. Output voltage will become negative due to the sudden switching operation, but the current will become current continue in its direction, that is current is positive. At a particular instant, the diode current D3, D4 will be decays to 0. At that particular instant, T3 and T4 turns on and the current direction opposes. T3, T4 turns on, the current direction reverses. That is, the current direction is from B to A when T3, T4 conducts, but the voltage is always negative. Okay, this is the operation of a single phase full bridge inverter with the resistive inductive load. Okay. Okay. This is the source voltage waveform. Okay, thank you.